We are looking to enhance the Hungry Traveling Snake project from the WiByte Python curriculum available at www.wibyte.in. We have a very interesting idea over here, which is to create what I call a poison fruit. Notice we have an extra triangle appearing on the screen. If my snake head were to go and try to eat that, which I'll do now, for example, you will notice the game gets over and I get a message saying poison. In this video, we'll see how we go about doing this and what is some care that we must take as we build a feature like this. Now, of course, you can extend this further. You can say that I'll have multiple poisons on my screen. That is something perfectly fine. The idea to create the poison fruit is not very hard. We just create a new turtle and place it at a random position. For reasons that will be a bit more clear a little bit later, I will do this after all the foods have been done. And I will also, in order to get the game to get over, I will just do whatever I was doing for, let's say, the playing boundary. I will say that if look, my distance between the turtle head and the snake head and the poison becomes less than, let's say, a certain number, in this case 20, I will get my game to be over exactly for the playing boundary. And here, instead of, let's say, collision, I will write, for instance, poison. So I know how this game got over. So that's really what I'm going to do. But there's a little bit of care we must take, and I'll come back to that having done this much. So let's just get back to our code. Now here I have, like I said, I'm going to create a new turtle at the end of, let's say, so just copy this whole thing over. In fact, I'll just copy this whole thing over. I will do this here. Let's say create a, say, poison, poison, and a poison. I'm going to create a new turtle. So let's just call it poison. Of course, I must do, okay, not poison, say poison. I'm going to copy this thing. See, of course, I must do all of this arrangement for the poison as well, the regular stuff, so that the poison can go to, let's say, a different shape. Now I'm going to give poison a shape of a triangle so it's easily visible. And I will give it a color, let's say gray color. Now again, this is something you can do differently, but here I'll just call it, say, dark, say, gray. And then having done this, I'll send my poison to a random position. So to a random position. Let's see this much working. So when I do this, I expect a new turtle to appear over there. And notice, indeed, I do see a poison over here. So instead of color, I'm just going to make the color to be, let's say, fill color. Now, having placed the poison, let's now come back and build the code to, let's say, make it poisonous. So I just get back to my code here. Remember, previously I had this code where if I hit the boundary, my game would get over. In fact, I'll copy this entire code over and I will paste it over here. But I must update the comment here. I say, okay, look, eating a poison. So eating a POI. So when. Now the way I'm going to figure this out, like I discussed earlier, if t dot, let's say, distance to, say, poison, because remember poison is the name of the turtle. So I just say if t dot distance poison is, let's say, less than 20. Now 20 seems reasonable because approximately the size of the poison as well. If this happens, then the game is over. Let me just remove this so that it's clear. So I just say, okay, look, if the poison is coming to me, let the game be over. Everything remains as it is. Here I just go and say, for example, poison. So I have this poison coming up here. This time I'm eating. Let me go and eat the poison and I expect the game to get over. Indeed, that's what happens. So everything just wipes off and I get this thing called poison. We need to take a little bit more care here while placing this poison, because it may happen that the poison goes and falls exactly on a fruit. Like, for example, I've shown here. Now this is going to be problematic because when my player tries to eat the fruit, very likely it will also end up eating the poison. So this is not acceptable. We must make sure that the poison ends up far from every fruit, all of the foods, and that is perfectly fine. So we need to actually make this in a code. Of course, you might argue that if this situation happens, let me just restart the game. That's also fine in a way. But if you want to make this robust from the code, it's interesting in its own right. What we will do is that we will make sure that the poison stays away from all the foods that have been placed. And this is why I'm placing the poison after the foods. So I will run a loop here. I'm saying, okay, look, I'm going to place this, in a way that I'm going to place it randomly earlier. But now notice it's part of a while loop. I say, okay, look, I'm going to check for this distance between the foods and, let's say, if any of them is less than 40, I'm going to do this once again. However, If all of them are, let's say, above 40, so this condition is not holding. If my food is the last food in this list, notice list of foods is a list of all the foods. If I'm on the last food here, then that means I've successfully placed the poison, and hence I can stop trying to place this again. So this will ensure that poison never falls on top of a food. In fact, stays, let's say, at least 40 pixels away, which is good enough because remember my touching condition is all less than 20. Let's just do this, this like a little bit of robustness here. Quite interesting activity, quite interesting exercise in programming itself, right? So I'll just come and, let's say, go back to my code over here that we are developing. Remember, I'm placing my poison right now, let's say just once, but I will not do that anymore. I will create a Boolean variable here. Let's say call it placed is equal to, say, false. I set it to false, and I run a while loop then saying that while, let's say, not placed, right? So while not placed, I will, basically, if this is the case, I will indeed place my poison. Having done this, I will check if my poison is close to any of the foods, and I can do that using a for loop. So I say look for, let's say, food, in, say, list of foods, for food in list of foods. I will, because these are all the turtles that I'm looking at, so I'm just going to check if the distance, say, so if, say, poison dot distance, so poison dot distance to the food. So basically I'm checking every food. If this distance is less than 40, it means that my this placement was not good because one of the foods is close to the poison. So I just say put a break here. I don't need to check for anymore. On the other hand, if let's say since I'm running through this loop, if I find that I have been able to successfully not break my code till I reach the last food, so I just put a condition here. If food is, let's say, equal to list of foods minus one. Remember, all the foods are in the list of foods. So if I've reached to the point where I've reached the last food, and that is also not less than 40. So what this means is that, I have not broken off from this for loop, and hence I have come to the last food. So if this indeed happens, I'm going to set placed is equal to true. Now with this done, I can be sure that the poison will always stay away from the all the foods. Now this is in fact quite interesting because there's a lot of thought processing going on here. We are looking at this two-dimensional space and seeing how we can place these things so that they all maintain a certain distance. This is a recurring theme that keeps coming up in this, as we look at more enhancement ideas, and hence this kind of code is actually quite interesting. Let's see this working. My poison is always ensured, is kind of guaranteed to be not very close to any fruit, and that is quite interesting. Of course, if I go and eat the poison, I will still die, like it happens here, right? So this is actually quite interesting. Like I said, several enhancement ideas that we look at will come into this. I will use a code of this sort, and in general, it's very interesting to think about that. I want to keep these things far away from each other, maintaining a certain distance. How does that placement look like? How many such things I can place, and so on. Those are pretty nice mathematical problems with a lot of practical implications. I hope you found this interesting. In general, if you think this way of learning is fun, building activities, thinking through their enhancements, implementing the enhancements, reasoning them out, look at our website www.wibyte.in because we have many, many, many such activities for you. Take care. Thank you so much. Enjoy programming.